Lesson 36, Confidence Interval Estimation for the difference in two population means. Example 1. Researchers interested in determining the difference in the mean IQ test scores of elementary school children who were breastfed as infants and who were formula-fed as infants administered standardized IQ tests to a random sample of elementary school students. The 82 children tested who were breastfed had a mean IQ test score of 104.7 with a standard deviation of 13.6. The 118 children tested who were formula-fed had a mean IQ test score of 99.4 with a standard deviation of 15.2. Based on the researchers' results, estimate the difference in the mean IQ test scores of elementary school children who were breastfed as infants and who were formula-fed as infants, using a 95% confidence interval. So in this example, we're going to estimate using a 95% confidence interval. So we'll be constructing a confidence interval using the customary 95% confidence. What we're estimating is the difference in the mean IQ test scores of elementary school children who were breastfed as infants and who were formula-fed as infants. So the mean is the mu, and children who are breastfed is one population, and children who are formula-fed is a second population. We're estimating the difference, so we'll be looking at subtracting mu1 minus mu2, and we're estimating with a confidence interval by saying that this difference occurs somewhere between some lower limit L and the upper limit U. Here in this case, where the first population is the children who are breastfed as infants, and the second population is the children who are formula-fed as infants. So, in this example, we'll be constructing a confidence interval estimation for two population means. So, we'll use the following results to take us through the steps of constructing our confidence interval estimate. First, with the level of confidence, we'll be using the customary 1 minus alpha equals 0.95. Next, the 2SAMP TINT command. This is where we use the calculator to help us construct our confidence interval. But in order to construct the confidence interval, we need to have our sample data. So when we're told that the children tested who were breastfed had a sample of 82, the children who were breastfed as infants is our first population, and the 82 children tested was our first sample size. So here we know that N1 equals 82. Now this sample had a mean IQ test score of 104.7. Thus the first mean, x bar 1, equals 104.7. With a standard deviation of 13.6, tells us that our first standard deviation, Sx1, equals 13.6. Now when we're told that the 118 children tested who were formula-fed, this is our second population, and then the sample, 118 children tested, is our second sample size. So N2 equals 118. This sample had a mean IQ test score of 99.4, so the second sample mean, x bar 2, equals 99.4. With a standard deviation of 15.2, tells us that the second sample standard deviation, Sx2, equals 15.2. So these sample statistics can be used in the 2SAMP TINT command to construct our confidence interval. To do this, we press Stat, arrow over to Tests, and then we arrow down till the cursor gets next to 2SAMP TINT. We press Enter. Now what we have for input is the sample statistics. So we arrow over to Stats, press Enter to select, and then down arrow. Now we enter in the sample statistics, starting with x bar 1, which equals 104.7. Enter. And then Sx1 equals 13.6. Enter. N1 equals 82. Enter. X bar 2 equals 99.4. Enter. Sx2 equals 15.2. Enter. N2 equals 118. Enter. The confidence level is 0.95, the customary level. Pooled is no, because we're not doing the pooled approach. Down arrow to calculate. We press enter. Underneath the toSAMPTINT command is the confidence interval, in parentheses, separated by commas. The first number represents the lower limit L, and the second number represents the upper limit U. So here, if we round off to one place after the decimal, we get 1.3 less than mu1 minus mu2 less than 9.3. So now that we've expressed our confidence interval symbolically, we can now express our confidence interval verbally. Based on the researchers' results, the difference in the mean IQ test scores of elementary school children who were breastfed as infants and who were formula-fed as infants is estimated to be between 1.3 and 9.3 IQ points with 95% confidence. Here, both the 1.3 and 9.3 are positive. This indicates to us that the first mean, mu1, is higher than the second mean, mu2. The first population were the children who were breastfed as infants. So we can make the following conclusion. Therefore, it is estimated that children who are breastfed as infants have anywhere from 1.3 to 9.3 IQ points higher mean IQ test scores in elementary school than children who were formula-fed as infants.